Hello students, welcome to AskPrep. My name is Gagana. In the previous class, we studied about the classification of elements and periodic properties. Now, we'll continue with the same topic. So, we studied S block and P block elements. Now, we are going to study D block elements. So, these D block elements are present in the middle part of the periodic table, that is between S and P block element, and they constitute 3B to 7B, 8, 1B, 2B, that is from 3 to 12 groups of the modern periodic table. And the outermost electronic configuration is N-1, D1 to 10, Ns1 to 2, that is N is equals to 4 to 7. And there are 4 series of D block elements which are 3D series, that is scandium 21 to zinc 30 to 4D series, that is yttrium 39 to cadmium 48, and 5D series is lanthanum to hafnium to mercury, 60 series is actinium to rhodesium, that is Rf 104. Up to UNB, BM and 1112, which is incomplete. So then what are the characteristics of D block elements? They are hard, ductile, malleable metals with high melting and boiling points. The ionization energy is between S and P block elements. They show variable oxidation states and are good conductors of heat and electricity. And they form both ionic and covalent compounds, and these compounds are generally colored and paramagnetic in nature, which consist of unpaired electron. And these transition metals basically forms alloys. F block elements. These are placed separately in the main periodic table and they are related to third B group, that is group 3 of the periodic table. There are 2 series of F block elements, that is 4F series and 5F series. 4F series are lanthanides which consist of 14 elements, that is Ce2Lu. 5F series actinides from thorium to lawrencium. The outer electronic configuration of F block elements are N-2 F1 to 4, N-1 S2, N-1 P6 and N-1 D0 to 1 NS2. So N is equals to 6 and 7. So the characteristics of F block elements are: they are heavy metals with high melting and boiling points, and they show variable oxidation states, and their compounds are generally colored. Most of the elements are anthanide series are radioactive. And the elements are classified into 4 groups based upon their incomplete shells which is present. Inert gases consist of S and P orbitals, where the outermost shell of these elements are filled. The outermost electronic configuration is Ns2 Np6. An exception is helium element, which is also an inert gas, but its electronic configuration is 1s2. So the next is representative or normal elements. The outermost shell of these elements is incomplete. The number of electrons in the outermost shell is very less than 8, and the inner shells are completely filled. S and P block elements, except the inert gases, are called normal or representative elements. So the next is transition elements. The outermost and the penultimate shells are incompletely filled, and the last shell, which is consisting of 1 or 2 electrons, and the penultimate shell may contain more than 8 or up to 18 electrons. Their outermost electronic configuration is similar to d block elements, that is n-1, d1 to 10 or ns1 to 2. And these elements have partly filled d orbitals in a neutral state or any stable oxidation state are called transition elements. An exception of this transition elements exhibiting different property is zinc, cadmium and mercury. They are d block elements, but these elements have d10 configuration in neutral as well as in stable +2 oxidation state. So the next is inner transition elements. In these elements, the last three shells, that is last, penultimate and pre-penultimate shells are incomplete. These are related to group 3. And the last shell also contains of 2 electrons. The penultimate shell may contain 8 or 9 electrons. And the pre-penultimate shell consists more than 18 up to 32 electrons. And the outermost electronic configuration is similar to that of F block elements, that is n-2 F1 to 14, n-1 S2, n-1 P6, n-1 D0 to 1 and ns2. Elements of the 7th period after the atomic number 92, that is actinides, are synthetic elements, and these are called transuranic elements as they are synthetically prepared. The next one is atomic radius. Atomic radius is taken as the distance between the atomic nucleus and the outermost shell of electrons of an atom. The size of the atom is very important because the physical and the chemical properties of atom are related to it. According to the Heisenberg's uncertainty principle, the position of a moving electron cannot be accurately determined. So, the distance between the nucleus and the outermost electron is uncertain. So, atomic radius can be determined directly or indirectly from the internuclear distance between the two atoms in the gaseous diatomic molecule. This internuclear distance between the two atoms is called bond length. So the next is covalent radius. So 1/2 of the distance between the nuclei of two covalently bonded atoms in a homodiatomic molecule is called covalent radius of that atom. The covalent bond must be single covalent bond, and the covalent radius of atom A in molecule A2 is given as the distance between the nuclei of two singly covalent bonded atoms in a homodiatomic molecule is equal to the sum of the covalent radii of both the atoms, that is dA minus A is equal to Ra plus Ra, that is for the two molecules it is given Ra plus A. In heterodiatomic molecule AB, where the electronegativity of atoms A and B are different and the experimental values of the internuclear distance dA minus B is less than the theoretical values, that is Ra plus Rb. So here delta X is taken as the electronegativity difference with a value of minus 0.09. So according to the Pauli's electronegativity principle, if the electronegatives of the two atoms A and B are Xa and Xp respectively, then the below formula is given, and C1 and C2 are the Stevenson coefficients of atoms. So the next is metallic radius. Metal atoms are assumed to be closely packed spheres in the metallic crystals, and these metal atom spheres are considered to touch one another in the crystals. So 1/2 of the internuclear distance between the two closest metal atoms in the metallic crystal is called metallic radius. So metallic radius is greater than covalent radius. So metallic radius and covalent radius of potassium are 2.3 angstrom and 2.03 angstrom. Van der Waals radius or collision radius. The molecules of nonmetal atoms are generally gaseous. On cooling, the gaseous state changes to liquid, which is followed from the solid state on further cooling. So in the solid state, the nonmetal atom or element usually exists as an aggregation of molecules and are held together by van der Waals forces. So van der Waals forces is the 1/2 of the distance between the nuclei of two adjacent atoms. This belonging to two neighboring molecules of an element in the solid state is called van der Waals radius. So it may be also defined as the 1/2 of the internuclear distance of two non-bonded neighboring atoms of two adjacent molecules. So van der Waals radius is greater than metallic radius is greater than covalent radius. The van der Waals radius and covalent radius of fluorine atom are 1.80 angstrom and 0.99 angstrom respectively. Ionic radius. A neutral atom changes to the cation by losing one or more electron and to convert into anion by gaining one or more electrons. The number of charge on cation and anion is equal to the number of electrons lost or gained respectively. The ionic radius of the ions present in an ionic crystal is calculated from the internuclear distance between the two ions. Radius of cation. So radius of the cation is comparably smaller than that of the neutral atom. Sodium is 1s2, 2s2, 2p6, 3s1. Sodium plus or 1 electron lost is 1s2, 2s2, 2p6 and 3s0. So the number of electrons are 11. Here the number of electrons are 10. Number of protons are 11 and here the number of proton is 11. The reason is the effective nuclear charge increases. For example, in sodium atom, 11 electrons are attached or attracted by the 11 protons. In sodium plus 10 electrons are attracted by 11 protons. Thus, in the formation of cation, number of electron decreases and the nuclear charge remains the same. Thank you for watching. Have a nice day. And if you have any doubts, feel free to comment in the comment box or mail us at AskPrep. Thank you.